Good evening, everyone. Welcome to 127th video on misconceptions in physics. My name is Ratankar Rao. I teach physics in a school, and my hobby is to do physics videos, especially on solving the doubts of students, which I receive through email or WhatsApp. I have a group of students and alumni of students, so whom they regularly keep on contacting me. I've been teaching physics for the past 20 years. So in fact, my students, their children, so we have a big group. Okay, without wasting our time. So far 126 videos have already been done. I take up several problems from either from the doubts which the students get or maybe from the papers which I do grade, and thereby I have made a repository of this. My interest is to continue doing this, and apart from it, I also do one-on-one coaching for a variety of courses like JEE Mains, IBDP, IGCSE, and so on. If anybody is interested, you can always enroll. Okay, you can call me back. This is my number, and my if you want to see all my courses, all my videos that I have done so far, then what you can do is you can refer to my YouTube channel, or maybe you can also visit my web page. My website is over here, which is ratankar.com. Let me move aside so that you can see my URL. So this is my URL, and you'll be able to see this, and you will be able to visit this, and hence you will be able to access all my lectures completely free. Okay, let us do 127th. My target is something like to do at least 365 videos, and shortly we'll be starting something on Olympiad problems. Some students have requested me that they also wanted to do something on Olympiad problems. So let me also try doing it currently in the recording stage. Okay, and Olympiad problems are very hard nuts to crack. And so as a result of this, I'm just taking up these problems, trying to see to it that how easily problems could be explained instead of making it more complicated, how much information to be provided, and if at all, if it is needed to be provided. Usually, I'm thinking of something like initially I provide a concept, a detailed concept, and then finally provide the solution. Sorry, put up across a question and then provide a solution. I think that'd be better, and moreover, Olympiad problems are very interesting. The reason is because you will get to know, you'll be able to cover more number of concepts, the stringed concepts. That's where it has been useful. Okay, I have spoken much today. Let me begin directly. Right, we are working on the logical reasoning errors. So there are some errors which arises. Oh my God, where is this? Due to logical reasoning, and as a result of this, students make a lot of mistakes. Okay, now using time in different contexts is a thing. What is so special? Let us read this problem. It's a very simple problem. The problem was very lengthy, but I have truncated it to whatever extent is needed here to explain the error. So uniform rod of mass m and length L is struck at an end by a force F perpendicular to the rod for a short interval of time. This is my cursor. Yeah, it's here. Okay. So you have a rod, an uniform rod, and then of mass m. This mass is m and the length is L. Length is L over here. And then you struck it. You strike it here with a force F. And that too, perpendicular rod F for, read this, for a short interval of time. Very, very important. That's why the title itself is something related to time. Okay, time. So why should I give this short interval of time? Right? There's something meaning here. So anything in physics, if you have to be very careful about the phrases. Now, calculate the speed of the center of mass. Where does the center of mass lie? Center of mass will lie at the center of the rod. Good. Angular speed of the rod. What is angular speed? Linear speed means the particle moves in a straight line. What is angular speed? The particle moves in an angle, right? That's what you call as angular speed. Okay. So assume that t is so small. T is so small. See, there's a particular phrase given here. This is a problem taken from H.C. Verma. That's what I see. Assume that t is so small that the rod does not appreciably change its direction when the force acts on it. Okay, which means when you are applying a force, the rod does not appreciably change its direction, which means what? When during the duration of the force, you applied a force, let us say 10 Newton force you applied. I have this object, you applied a force of 10 Newton. Okay, when I applied, it was so fastly applied, it was so rapidly applied that during this application of this force, the rod does not change its direction. Then why does it change its direction? Because you gave some force. The consequence of the force is, it is nothing but an energy. You are given some energy, and as a result of it, this energy should do some work. Okay. Anywhere, anything that you see, whenever you are providing some energy, it should do some work. As simple as that. So it does some work. What does the work do? It tries to either move the rod, it tries to rotate the rod, does something. Okay. So simple. Now, what does the student do? The response given by the student is like this. It says that Ft is equal to mv. What is Ft? Force multiplied by time. Why did he use this? Simple thing. He has just considered F is equal to m into v minus u divided by t. What is this? Newton's second law, right? You all know about this. Now, what is u? Initial velocity. What is initial velocity? Zero. The rod was at rest. So, therefore, I can write this as m into v minus 0 divided by time taken. This v minus 0 is just v here. So thus I get this as mv divided by t, and thus you can write v is equal to ft divided by m. Ft divided by m is nothing but your v. Okay, what is this v here? He says that v is nothing but the, see, is v is nothing but the speed of the rod at this end. Wherever you strike here, this is the velocity which he is talking about. Now, what is it I asked? The question here is calculate the speed of the center of mass. What is the speed at this point? Now, how do we do it? Right? This is the question. So very interesting, right? So now, interesting for me, not for you. Okay. So maybe it is interesting for you also. Okay. Let us see this. Now, what he did was that he found out what is the angular velocity. How do you find angular velocity? Now, the question comes here. How do you find angular velocity? Now, what he assumed? He assumed that omega is equal to v by L. When I look at this equation, what comes to my mind? It says that v divided by L. What is v by L? V by L, omega is equal to v by L. We can use it only when we consider v by r is equal to omega or v is equal to r omega. What do you mean by that? Which means that this is the velocity and this is the r. Now, what did he assume? He assumed that the rod is pivoted here. Is it given anywhere? No. Unnecessarily, we think, we assume, we imagine saying that, okay, rod is pivoted, I applied a force, and hence the rod moves like this. Does it happen? No. Nowhere it is been given here, right? So therefore, you should not consider this. This is where he made a biggest mistake here. So when he makes this mistake, then totally his misconception happens over here. Thus you see omega equal to, he just consider omega equal to ft by ml, and hence the center of mass speed is nothing but omega L by 2. Okay, what does it do? Well, the entire part of it rotates with the same angular velocity omega, and this is nothing but L by 2, half of the length of the rod, and thus v is equal to omega L by 2. Thus he considers ft by 2. He answers both of them, and both of them are incorrect, right? Now let us see how to solve this. Okay, so the misconception here is we assumed that the end of the rod is pivoted, which indeed is not possible, which is not being seen, which is not being given in the example. Okay, now let us solve this. Now the solution here is that it tells you that you are striking it with a force F, and when you strike it, maybe for 1 nanosecond, when you strike it here, the object did not move, which means what? Okay, so you applied a force, then this was an impulsive force. Thus, the velocity at which this started moving and the velocity at which this started moving, or the velocity at which this end started moving, all of them are one and the same. Do you agree? Okay, all the ends initially started moving with the same velocity. Okay, because nowhere it has been pivoted. If it is not pivoted, why should one of them held here? Why should one of them move faster? Why should one of them move slower? And I have not given you the friction also here. So all the ends we have started to move the same velocity, which means the velocity at this end and the velocity at this end are one and the same, right? This is what we need to infer. Thus, the center of mass velocity is v is equal to ft by m only, nothing else. V is equal to ft by m. The next is angular speed of the rod. Now, angular speed, how do I calculate angular speed? If I want to calculate angular speed, there should be something pivoted here, right? Okay, where is it pivoted? No pivot is given here. Then what is the angular speed here? Now remember, when you have a big rod like this, the entire mass is seen to be focused at this point. So when you apply your force over here, there's every possibility that this will start moving like this, right? Above the center of mass, it can rotate like this, right? It will not completely rotate. It will not stand here and rotate. Okay, the moment you put a force, it can slightly move and then it can move like this, right? So now you need to find out what is the angular speed. The angular speed of the rod is nothing but omega is equal to v divided by L. Just a moment, there's something wrong. Okay, I just figured it out. My PPT just hung for a second. Yeah, now once again. Now the next is, now how do I calculate this angular velocity? That's what I was explaining. You cannot use these kinds of methods over here. Very difficult, okay? Unless it's been pivoted, you should not use omega equal to V by L, which is wrong. Okay, so therefore, you cannot use omega equal to V by L or omega equal to V by L by 2. Everything is incorrect here. You cannot use all these methods. Now, what is that we need to use? Now, let us think for a while. You have a rod, you have an object. This object came and hit here. The moment hit here, what do you mean by hitting? Which is nothing but a collision, right? Collision. So therefore, there is a collision that's happening. So when you have a collision, which law can you use? Okay, the law that you can use here is conservation of angular momentum. Are you getting me? Conservation of angular momentum. Now, what is this conservation of angular momentum? Conservation of angular momentum tells you that the angular momentum of the particle initially before anything happened, the initial angular momentum was seen to be mv into L, right? mv into L. Okay, uniform mass m stuck with a force F. So therefore, mv into L, this should now be equal to, then what happened? The object started moving about the center of mass. Then it is ml square by 12 multiplied by omega, right? mv into L should now be equal to ml square by 12 into omega. I think we are missing something. This L is nothing but L by 2 here. Why L by 2? Because about the center of mass. What is this equation? Do you remember this? Is nothing but your MVR, right? MVR, what is MVR? Mass velocity, then the distance with respect to the center of mass with respect to the fixed point, or maybe with respect to the where the force was acting, not even fixed point, with respect to the force where it is acting. So with respect to the center of mass, the force is acting here, and this distance is seen to be L by 2 over here. So that's, I can write mv into L by 2 is equal to I into omega. I into omega. What is I? Moment of inertia. Moment of inertia of what? Of the rod with respect to the center of mass over here, which is ml square by 12 into omega. Now let us solve this. So you get this m and this m goes away. Then you have, hey, this is 2. 2 ones are 2 6 are, right? 2 6 are, and then you have this L, and this L also goes away. And thus what am I left out with? I'm left out with omega is equal to 6V divided by L. Okay, 6V divided by L. And what is V here? Velocity of center of mass, which we have already calculated over here. Let us substitute this. This could be written as 6, 6F. See, if I write one letter, other letter vanishes. Oh my God. Omega is equal to 6Ft. Oh, it's giving me a lot of time. Okay. Omega is equal to 6Ft. What was V is equal to 6Ft divided by M. Okay. This is the expression for omega. I hope you have understood this way of solving the problem. Remember, whenever there is a collision, okay, and the end is not pivoted, you are not supposed to use omega equal to V by L. Okay. Only when the end is pivoted, you can use omega equal to V by L. That means if it is pure rotation, V equal to R omega should be employed only when there is a pure rotation. Here what's happening? There's no pure rotation here. Okay. It was standing like this. You applied a force here. Now you see, as it is applied, it can either rotate like this or it can also slide like this and move. Okay. If it is sliding like this, then definitely it is not pure rotation. Okay. So I hope I have made my point clear. So this is a common mistake which every student does it in every part of the problem. See to it that when you are solving rotation, first understand whether it is a pure rotation or a sliding plus a rotation. Okay, what is sliding plus rotation? Rotation means it rotates like this. Okay, with respect to elbow, my elbow does not move. Okay, I just rotate my hand like this. This is pure rotation. Now, what is hybrid rotation? Which means that the elbow also moves and this also moves like this. Okay, see, this is now a hybrid rotation, wherein the elbow is now sliding like this. It's coming towards like this, and this hand is also moving like this. This is called as a hybrid rotation. So whenever you have something like this, do not use your V equal to R omega. Okay, I hope I have made my point clear. Thank you, friends, for being with me, making it successful, and see you in the next video. Don't forget to share, and subscribe to my channel for more updates. In fact, I'm just adding some music and all other things for the previous video. So it's not a new video. Yesterday also I had added one video on vectors. Okay, it is just adding some masala to it. Okay, it makes more attractive. So that's why I put it across. The older videos you will be often seeing it. But anyway, every day, evening 7 p.m., you'll be able to see this video being broadcasted. Thank you.